So it's the middle of summer, right? You walk into your house after being outside for maybe 10 minutes, and you look like you've just run a 5K. Your shirt's sticking to you. The air inside feels thick, and honestly, the fan is just making things worse at this point. You hit the button on your thermostat. You hear that quiet click from the outdoor unit, and within a few minutes, the whole room just shifts. That sticky, heavy feeling disappears. You can breathe again. Now here's something most people never stop to think about. That moment, that little miracle of modern comfort, it didn't come from some random factory pumping out cheap boxes. For a lot of people around the world, that moment came from one company that has spent literally 100 years obsessing over one single problem. How do you move heat from inside a building to outside it as efficiently and quietly as possible? That company is Daikin. And today, we're going inside their factories to actually see how these things are built. Because once you understand what goes into making one of these units, you start to realize that what's sitting on your wall is a lot more impressive than it looks. So Daikin started in Osaka, Japan, back in 1924. And look, I know that sounds like the kind of fact you'd skip past, but stay with me here. Because 100 years of doing one thing really does change what a company is capable of. Right now, Daikin operates in over 160 countries. They run more than 90 manufacturing plants around the world, and they're pulling in somewhere around $30 billion a year. In the US, the UK, Canada, and Australia, their systems are everywhere. Hospitals, office towers, data centers, and millions of homes just like yours. But here's the thing about Daikin that most people don't know. A lot of air conditioning brands are basically assemblers. They buy the most important parts from other companies, put them together, and slap their name on the box. Daikin doesn't do that. They make their own compressors, they design their own coils, they develop their own refrigerants. That might sound like a small detail, but it's actually a huge deal. And I'll explain exactly why in a minute. First though, let's talk about what an air conditioner is actually doing. Because there's a really common misconception here that I want to clear up. Your AC is not making cold air. There's no cold generator inside it, no place where coldness is being manufactured. What it's actually doing is pulling the heat out of your room and throwing it outside. That's it. Cold is just what you feel when the heat is gone. The whole machine, every single component inside it, exists to do that one job. Move heat from inside to outside, over and over again, as long as you need it to. And the way it does that is actually kind of fascinating once you get into it. It all comes down to a fluid called a refrigerant. Now, the refrigerant inside your AC has one really special property. It changes between liquid and gas at a very low temperature, much lower than water does. And that matters because of something that happens whenever a liquid turns into a gas. It absorbs heat from whatever is around it. And when that gas turns back into a liquid, it releases that heat. That cycle, absorb heat here, release it over there, is the entire engine that makes your house comfortable. Now inside a Daikin factory, the process of building a system that does this reliably, quietly, and efficiently for 15 or 20 years, that's where things get genuinely interesting. It starts with copper, and not just any copper, specific grades, specific tube diameters, specific wall thicknesses. The factory has machines that take this copper and bend it into hairpin shapes with tolerances that are honestly ridiculous when you see them. A fraction of a millimeter off and airflow through the coil is compromised. The geometry of those bends determines how well the refrigerant inside can absorb heat from the air passing over it. Daikin engineers have run thousands of simulations on coil geometry over the decades. And what you're seeing on that factory floor is the physical result of all of that work. Alongside the copper tubes, you've got aluminum fins being stamped out by the millions. These are the thin metal sheets that get threaded onto the copper to create what's called the heat exchanger coil. If you've ever looked at the outdoor unit of a split system and seen that grid of thin metal fins, that's what I'm talking about. The spacing between those fins, the tiny texture on their surface, the angle they sit at, all of that is calculated to move as much air as possible with as little resistance as possible. It sounds like a small thing, but the difference between getting this right and getting it slightly wrong shows up directly in your electricity bill every single month. But the heart of the whole system, the component that everything else depends on, is the compressor. And this is where Daikin's decision to make their own actually matters in a really tangible way. The compressor's job is to take the refrigerant gas after it's absorbed heat from your room and squeeze it. Compress it. When you compress a gas, two things happen. The pressure goes up, and the temperature goes up with it. By the time that gas comes out of the compressor, it can be over 150 degrees Fahrenheit. Seriously hot. And that matters because now this hot gas can release its heat to the outdoor air, even on a warm summer day, because it's hotter than the air outside. The type of compressor Daikin builds is called a scroll compressor. Inside it, there are two spiral-shaped metal pieces sitting inside a sealed housing. One stays fixed, the other orbits around it in a tight circular motion. As it moves, it traps small pockets of refrigerant and squeezes them progressively smaller and smaller until they're forced out at high pressure. When you see these being assembled inside a Daikin facility, the precision involved is almost uncomfortable to watch. Robotic arms placing components at angles that are measured in microns, not millimeters. Because if the clearance between those two scrolls is even slightly wrong, efficiency drops, noise goes up, and the lifespan of the unit gets shorter because Daikin designs and builds their own compressors rather than buying them from a supplier. They have full control over every single decision in that process. If their engineers want to change the alloy composition of the scroll material, they can do that. If they want to tweak the motor winding to reduce vibration at a specific operating speed, they can do that. A brand that buys its compressors from someone else has to work with whatever decisions that supplier already made. So after the compressor does its job, and you've got hot, high-pressure refrigerant gas, it travels out to the outdoor unit and flows through the condenser coil. The outdoor fan blows outside air across it. The refrigerant dumps its heat into that air, and as it cools down, it does something really interesting. It changes state. The gas condenses into a liquid, just like steam becomes water when it hits a cold surface. And the heat that was sitting in your living room a few moments ago is now outside, carried away by the wind. Done. But the refrigerant is still under high pressure, and it's not cold enough yet to go back inside and absorb more heat. So it passes through a component called an expansion valve. This is a very small, very precisely engineered part, basically a controlled restriction that the refrigerant has to squeeze through. When it does, the pressure drops suddenly and dramatically, and when pressure drops fast like that, temperature drops with it. The refrigerant goes from warm, high-pressure liquid to extremely cold, low-pressure fluid almost instantly. You've actually felt this effect yourself. If you've ever held an aerosol can, while spraying it for a while, you've noticed the can gets cold. That's the same principle. The pressurized contents are rapidly expanding and dropping in temperature as they exit the nozzle. Now this cold refrigerant moves into the indoor unit through the evaporator coil. Your indoor fan blows the warm air from your room across it. Heat flows from the warm air into the cold refrigerant. The air that comes back out of your vents is cooler because its heat has been pulled out, not because something cold was added to it. And the refrigerant, now warm again from absorbing all that heat, heads back to the compressor to start the whole cycle over. One extra thing that happens at the evaporator coil. And honestly, this is one of the reasons an air-conditioned room just feels better, even before the temperature fully drops, is dehumidification. When warm, humid air hits that cold coil surface, the moisture in the air condenses into water droplets. That's the water that drips out of your outdoor unit into the drain. Your room gets drier, less sticky, more breathable. Daikin puts a lot of engineering into how efficiently this happens because they know that comfort isn't just about temperature. Now, let's talk about inverter technology, because this is the part that directly affects your electricity bill, and it's where the gap between a quality unit and a budget. One is most obvious, an older style non. Inverter air conditioner runs its compressor in one mode only, full speed. When your room hits the target temperature, the compressor cuts off completely. Then, when the room warms up a little, it kicks back on at full power again. On, off, on, off. This happens constantly throughout the day. And every time a big motor starts from a dead stop, it pulls a surge of electricity that's significantly higher than what it uses once it's running. It's a bit like if every time you slowed down while driving, you switched the engine fully off, then floored it again to get back to speed. You'd burn through fuel incredibly fast. Daikin's inverter compressor doesn't do that. It varies its speed continuously based on what's actually needed. Room getting close to target temperature, the compressor slows down gently rather than switching off. Room needs a bit more cooling, it speeds back up. It's always running, always fine-tuning, never doing that violent start and stop cycle. The result is a much more stable room temperature, significantly less energy used. We're talking 30 to 40% less in a lot of real-world comparisons. and a compressor that experiences far less wear over its lifetime. There's also the refrigerant question, and Daikin has made some pretty significant commitments here. The refrigerants used in older air conditioners had very high global warming potential, meaning if they leaked out of a system, the environmental damage was significant. Daikin has moved aggressively toward R32, a refrigerant that has around 68% lower global warming potential than the R410A it replaced. It also works more efficiently, so you need less of it in the system to do the same job. Less material, smaller components in some cases, less environmental exposure if something does go wrong. And before a Daikin unit ever leaves the factory, it goes through a testing process that's worth talking about. Every compressor is performance tested. Every coil is pressure tested at levels well beyond anything it'll ever see in normal operation. Every control board gets cycled through fault scenarios to make sure all the protection systems work the way they're supposed to. This isn't random sampling where you test one unit per 100. It's comprehensive testing on every single unit. Because when something is going on your wall for the next 15 to 20 years, the cost of one failure in the field is much higher than the cost of thorough testing before it ships. So the next time you're standing in your living room on a hot afternoon, and the air just feels right, the temperature is exactly where you want it. It's not too dry, not too humid, and you can barely hear the system running. Just take a second to think about what's actually happening. Outside your house, a scroll compressor that was assembled with micron-level precision in a Japanese factory is spinning at exactly the right speed. Copper coils that were bent and shaped by machines running programs that took engineers years to develop are transferring heat from inside your home to the outside air. A refrigerant chosen specifically for both performance and environmental impact is cycling through the system doing exactly what it was designed to do. It's been doing this quietly, without any drama, since the day it was installed, and it'll probably keep doing it long after you've stopped noticing it's there, which honestly is the best thing you can say about any piece of engineering. That it just works so well that you forget it exists. If you enjoyed this one, subscribe because we put out videos like this every week. Drop a comment and let me know what AC brand you're running at home right now, and whether any of this changed how you think about it.